In the first part of Chapter 2, we talk about the Ionian's school and Thales. In this video, we want to illustrate his most important contribution in math, which is also called Acetics Theorem. This theorem stated that the angle subtended by a diameter of a circle at any point is a right angle. To illustrate it in figures, it's like this. We first draw a circle with the center A, then pick a point B, draw a diameter BC. Then we can pick any points on the circle, like D here. Then we can connect CD and BD. And the Thales theorem stated that the angle CDB right here is a right angle, and it doesn't really matter how we move it. Like we can move this point D around the circle anywhere, doesn't really matter. The angle CDB is always a right angle. Before we start the proof, we need to assume a few knowledge that Thales already known. First of all, it's the definition of a circle, which means that Thales know the distance between the center and any points on the circle is the same. We call them radius now, but the word radius doesn't exist in the 6th century BC. Second, the sum of all interior angles of a triangle is 2 right angles. We didn't really say the sum is 180 degrees here, which is also because such angle measurement doesn't exist around that time. Third, the base angle of an isosceles triangle are congruent. Now let's see how do we prove this theorem. First of all, we have to connect this point to the center of the circle. Then in this graph, we have 3 radius, which is AC, AD, and AB. By definition, we also know that they're all congruent to each other. Now if we look at the triangle ACD, we know that AC is equal to AD, that it is an isosceles triangle. The 2 base angles has to be congruent. We mark them X. In triangle ABD here, we have AB is equal to AD. It is also an isosceles triangle. The 2 base angles are congruent and we mark them Y. Now if we look at this big triangle, we can use the sum of all interior angles are 2 right angles. Then we can write X plus Y plus another Y, which is this 3 angles, is equal to 2 right angles. Let's write 90 degrees for our own convenience. Now with some algebra combining like terms, it is easy for us to write 2x plus y is equal to 2 times 90 degrees. Then we can divide it 2 on both sides. Then we have x plus y is equal to 90 degrees. Now we know the angle CDB is x plus y, and it is always 90 degrees. Then we're done. See you in the next video.